In this video, I'm going to find the slope of the tangent line for 3 particular functions. And then we're going to actually calculate the slope at a particular point on those 3 functions, and then write the equation for the tangent line that goes through those points on those 3 functions. So, to find the slope of the tangent line, we are going to use our definition of the slope of the tangent line. The limit as h approaches 0 of f of x plus h minus f of x all over h. So this is f of x, so I need to do f of x plus h, which means I'm going to use the function rule, put x plus h into the rule. Then I'm going to subtract f of x, which is the entire original function, all over h. And now we're just going to do the algebra and simplify. So 2 times x is 2x. Oops, forgot to put the limit. This is the limit as h approaches 0. Again, this is going to be the limit as h approaches 0. Don't forget these on your test. 2 times h is 2h plus 1 minus 2x minus 1 all over h. Again, this is going to simplify. We've done practice problems like this before. 2x minus 2x is 0. 1 minus 1 is 0, so I'm left with 2h over h. Simplifies one more time to the limit as h approaches 0 of 2. And we know that the limit of a constant is just that constant. What this is telling me is that the slope of the tangent line to this function is 2. And you should understand, because that is a linear function, yes, of course it's going to have a slope of 2 because it's in slope-intercept form, and that is the slope. Well, now it says to write the equation of the line tangent through that point. Well, for a linear function, that is going to be our equation. But let's check just in case we're going to just do it normally. Well, in order to write the equation for a line, we want to use the following formula. Y minus y1 equals m times x minus x1. We've already calculated m. Well, there's my x. Well, I need a y. So I'm going to take that x and do the function rule on it. 3 times 2 is 6. 6 plus 1 is 7. So I want to write the equation for the line that goes through the point 3, 7. So that would give me y minus 7 equals 2 times x minus 3, or y minus 7 equals 2x minus 6. Add the 7 to both sides, and I do get y equals 2x plus 1. Again, that should be no surprise, because the tangent line is actually the original line for a linear equation, that you will get the same answer. Now let's do the next one. I want to find the slope of the tangent, so that is the limit as h approaches 0 of f of x plus h minus f of x all over h. I'm going to write this as h over 1. This is a complex fraction. The way you get rid of a complex fraction is you multiply everything by the lowest common denominator of all of the little fractions. Lowest common denominator is x times x plus h. So I get x times x plus h times 1 over x plus h minus x times x plus h times 1 over x all over h times x plus h times x. I'm going to notice here that the x plus h's cancel here, and the x's cancel here, and now I can write it as a regular fraction. So I have x minus x minus h all over h times x plus h times x. I'm not going to multiply the denominator. You're going to see why in a second. Typically, you're going to leave this in its factored form. X minus x is 0, minus h is negative h. I have a limit as h approaches 0 of negative h over h times x plus h. Next, I see that I can factor an h out of the numerator and denominator, but divide both the numerator and denominator by h. So it gives me the limit as h approaches 0 of negative 1 over x times x plus h. This is now the first step that I can actually let h go to 0, not end up dividing by 0. So if I put a 0 in for h, I get x plus 0, which is 0. Well, x plus 0 is x, so I get x times x plus 0, which is h approaches 0, negative 1 over x squared. And for the purposes of taking the limit, h is my variable, so this is actually a constant. So the limit of a constant is what's left for that constant, and it would be negative 1 over x squared. So this is the slope of the tangent at any point along the curve 1 over x. It's going to meet the formula negative 1 over x squared. So if I want to find out what the exact slope is when x equals 1, I'm going to put a 1 into that function. 1 over 1 squared is negative 1 over 1 squared is negative 1. So the slope of the tangent line when x equals 1 is equal to negative 1. And if I want to write the equation for the line, I'm going to put a 1 into my original function to find the y-coordinate. If I put a 1 into my original function, 1 over 1 is 1. So I want to find the slope of the line at 1, 1. I want to write the equation for the line at the point 1, 1 that has a slope of negative 1. And again, I just use the equation for a line formula, the point slope formula. So I get y minus 1 equals negative of x minus 1. If you distribute on this side, you get y minus 1 equals negative x plus 1. And move the 1 to the other side by adding, you get y equals negative x plus 2. So this is the equation for the tangent line to this function through the point that has the x-coordinate of 1, or the point 1, 1. And our final example is for this function. So I know that the slope of the tangent line is equal to the limit as h approaches 0 of x plus h minus 1 minus the original function all over h. When we were doing our practice on limits before, when we had the square roots in the numerator, we multiplied both the numerator and the denominator by the conjugate of what was in the numerator here. I'm actually going to erase part of the board so that I can have more room. So my next step is going to be over here to the left. So it's the limit as h approaches 0 of x plus h minus 1 minus the square root of x minus 1 over h times the square root of x plus h minus 1 plus the square root of x minus 1 in both the numerator and the denominator. Remember, all this is doing is multiplying the equation by 1, but a special form of 1. This is a difference of squares pattern. So that gives me the limit as h approaches 0 of the first term squared, which is x plus h minus 1, minus the last term squared, over h times that whole thing, square root of x plus h minus 1 plus the square root of x minus 1. So that h is going to multiply by all of these. Again, from our experience, we don't want to distribute the h. I'm now going to simplify the numerator, which is the limit as h approaches 0. H plus 1 minus 1, x plus h plus 1, that's minus 1, sorry, minus x plus 1 all over x plus h minus 1 plus the square root of x minus 1. X minus x is 0. Negative 1 plus 1 is 0. I'm left with h over h in the denominator. X plus h minus 1 plus the square root of x minus 1. H over h is 1. So, still copying the limit because I have not taken it yet. So that leaves me with 1 over the square root of x plus h plus 1 plus the square root of x. Sorry, that's a minus 1 again. Minus 1. Minus 1. Notice now that if I let h go to 0, I'm not going to end up dividing by 0. So I can actually take the limit. So on the numerator, I get 1. In the denominator, that becomes 0, so I'm left with the square root of x minus 1 plus the square root of x minus 1. Any number plus itself is 2 of that number. So the final simplification would be 1 over 2 square root of x minus 1. Again, this is the general equation for the slope of the tangent line at any point along the function square root of x minus 1. The next thing I want to do with that function is I actually want to write the equation for the line for this function that goes through the x-coordinate of 2. Well, I can calculate the slope for the equation of the line that has the x-coordinate of 2 by putting a 2 into that function. So the slope of the tangent line when x equals 2 is equal to 1 over 2 square root of 2 minus 1. 2 minus 1 is 1. Square root of 1 is 1. 1 times 2 is 2. So the slope of the tangent line to that graph at x equals 2 is 1/2. Now I need to find the y-coordinate when x equals 2. So I put a 2 into the function. 2 minus 1 is 1. Square root of 1 is 1. So I want to write the equation for the line that goes through the point 2, 1. So I get y minus 1 equals 1/2 the quantity of x minus 2. Distribute. Y minus 1 equals 1/2 x. 1/2 times negative 2 is negative 1. Add 1 to both sides, and I get y equals 1/2 x, which is the equation of the line tangent to this function that goes through the point 2, 1.